Let's look at properties of logarithms. So we want to show that log base a of 1 equals 0 and that log base a of a equals 1. Now, if you're going back to my reminder that a logarithm is an exponent, then if I read this, it would say a to the 0 power equals 1, which makes sense. A to the first power equals 1. Well, let's actually show this. So once again, saying that a logarithm is an exponent. So that means this. So log base a. I typically write the value in parentheses, just what I'm used to. And so then here, if I change all of this to exponent, then I'm saying that I have a to the y power equals 1. Okay, so just going here based on our definition. And certainly I can see that I could rewrite 1 as a to the 0. Now we set our exponents equal to each other, and therefore that just simply proves that that equals 0. Kind of a weird, strange proof, but that's all there is to it. Same thing on the second one. If I write my a to an exponent equals a and equals that a inside, then I can write a, the same thing, to the first power, and I set the exponents equal to each other, and thus I see my proof that a logarithm is an exponent. A logarithm is an exponent. That's all it is. And so here we're going to get into some really good properties that you're going to see that you're going to use a lot in further classes. This property, if you have the same base raised to a logarithm of that base, students kind of like to say that cancels, which is fine. And so what's happening here is once we raise to the same base, we simply bring this power down. So that's a good way to, you're going to see later, to solve when you have your exponents in the or your variables in the exponent. The logarithm to a base a of a raised to the r. Same thing here, but just flipped the differences, right? The log now of the base a, and this also equals r. We're not going to go through the proofs, but if you're interested, you're like a major math person, right? You know who you are, then you certainly can look in the textbook. So as you can see, each one of these are just showing how to use that proof. Notice the bases have to stay the same, and so hence we bring down the exponent. Bases are the same. Remember, ln is base e, so same bases. These are probably the most important properties that I teach in further classes, certainly in calculus classes. So if you remember, when you multiplied with the same base, we said, what did you do with the exponents? You added them. And that's why I say, if you can get the exponent properties down, the logarithms are the same. What did you do with exponents when you were dividing with the same base? You subtracted them. So notice the same properties here. So logarithms multiply, separate by adding, dividing, separate by subtracting. And then here is kind of what we were just showing, that if I can bring this power. Now notice this doesn't cancel out, but a log of a power equals the product, so being multiplied now, of the power and the log. So let's actually look at writing a logarithmic expression as a sum or difference of logarithms. So we start out with this logarithmic expression, and what I want to do is I'm basically going to separate it in pieces. So the first thing that I'm going to do is I notice that that's being multiplied, and so multiplication becomes addition. So log base 2 of x squared plus log base 2 of our cubed root of x minus 1. So that's the first step, is to separate the multiplication as addition. Now what we like to do is we like to change all of them to exponents. meaning that nothing changes here. It's already an exponent, 2 plus log base 2. But remember that the, let me do it like this, that the cube root is the same as the 1/3 power, okay? And then I do my log of a power, which is the product of the log. So I bring the 2 down, log base 2 of x, bring the 1/3 down, log base 2 of x minus 1. And now what I've done is I have actually written this out as using my log properties. I went from a product all the way through all of my properties to an addition and subtraction, in this case just addition, but then using my power properties as well. So we'll continue on because these are very important properties with the next lecture with more of these.